Hi guys, Mr. Thompson here again. Your last lesson of this half term, force lesson number 9. Can't believe it's been 9 lessons since Easter. Quite short one today, no assessment today, end of term. You're not going to get any assessment, but do expect you to make the relevant notes in your book. So today's lesson objectives are that you will understand what's meant by acceleration due to gravity and that you understand what is meant by terminal velocity. Quite short lesson, as I say. So look at the spec. The two bits I want you to know is that near the Earth's surface, an object falling freely under gravity has an acceleration of about 9.8 meters per second squared, and an object falling through a fluid meaning liquid or gas, initially accelerates due to the force of gravity. Eventually, the resultant force will become zero. An object will move at a terminal velocity. We'll look at the terminal velocity of a skydiver. The first one's quite straightforward, but you get these notes in your book. An object near the Earth's surface falls in an acceleration of actually 9.81. Sometimes round off to 9.8, sometimes even round off to 10. It will tell you on the exam. So this is called the acceleration due to gravity. It will be given you on the exam paper. But worth remembering. Example, if you dropped a ball from the top of the Leaning Tower of Pisa, as Galileo did, how fast would we travel after 4 seconds? The acceleration is 9.81 meters per second, not per second squared. So it means that every second it increases by 9.81. So after 4 seconds, it will be traveling at a speed of 39.24 meters per second. Now that is true as long as air resistance doesn't have time or doesn't take effect. So a bowling ball or a small ball may actually reach that speed after 4 seconds. It will keep accelerating. But if there is air, it will take effect. So what I'd like you to do now is watch on my YouTube channel. I've put a link in the Show My Homework 2, a video, quite an old video, but it was the best one I found. I've been watching it for years, called Terminal Velocity of a Skydiver, just for 3 or 4 minutes. So you pause this video now and watch that. Okay. A few things to write in your book and then you're finished, okay? So a skydiver, you need to draw these diagrams and write with you. So initially, when he first jumps out of the plane, there is no air resistance. So he accelerates at an acceleration of 9.81 meters per second squared on Earth. After some time, air resistance will take effect and therefore his acceleration will not be as much. Then after a certain time, when he's traveling quite a speed, the air resistance will be significant enough to match his weight, and therefore you'll get balanced forces. More of this after half term. Balanced forces means he will no longer accelerate. He will travel at what's known as a terminal velocity, not getting any faster. And as you probably saw in the video, for a skydiver without a parachute, with just traveling like in the diagram, that would probably be a speed of about 120 miles per hour. Okay, if you get that down in your book, probably worth starting a new page because there's another diagrams after this one. Okay, so he now opens his parachute. What does that do? That increases the air resistance, a lot more air resistance than his weight. So his acceleration, he in fact decelerates, his speed slows down. It causes him to slow down or decelerate. But eventually, he slows down so much that the forces are balanced again. He reaches a new lower terminal velocity. This terminal velocity is low enough for him to land safely on the ground. So if you write that down in your book, then one more slide to go. Okay, a graph. This is often a 6-mark question, understand this. So worth to spend the time to sketch this graph. So the first section of the graph, if we're looking at a velocity time graph, his speed increases and he reaches a terminal velocity. And then when he pulls the parachute, it slows down. And then he reaches a new terminal velocity. And then eventually he'll hit the ground and his speed will go back down to 0. So his sketches in your book, probably worth drawing this extra line here. What if he did it on the moon? Well, the acceleration and gravity on the moon is about 1/6 of the Earth. So the gradient is 1/6. You'll notice that it's a straight line. Why is that? Because there is no air on the moon, and therefore if he fell from a rocket or a rocket ship above the moon's surface, he would just continue accelerating until he hit the ground. which could mean he actually could reach speeds higher than what you would on Earth. There's no way of slowing down, okay, unless he obviously had a rocket. Okay, if you get that down in your book, that's your last task today. And there we go for the term. Thank you for listening and getting all the notes and your assessments in, and have a great half term. Bye for now.